Hi guys, we're going to continue with chapter 7 of our astronomy. We're talking about stars and constellations, but really we're going to talk about how all this stuff may have begun, the Big Bang. But let's start with something a little different that we don't normally start with in science class, and that's a poem. This is a poem by Robert Louis Stevenson called Escape at Bedtime. And people have often looked up at the stars and have been inspired to write poetry or just look at their observations, and they are very emotional. And so if you're a poet and emotional, you write a poem. And let's read about this child looking out, being outside, and marveling at the stars at the night sky. Robert Louis Stevenson wrote a lot of poems about kids and what it felt like to be a kid. He must have remembered that a lot. This is called Escape at Bedtime. The lights from the parlor and kitchen shone out through the blinds and the windows and bars. And high overhead and all moving about, there were thousands of millions of stars. There ne'er were such thousands of leaves on a tree, nor of people in church or the park, as the crowds of the stars that looked down upon me and that glittered and winked in the dark. The dog and the plow and the hunter and all, and the star of the sailor and Mars, these shone in the sky, and the pail by the wall would be half full of water and stars. They saw me at last, and they chased me with cries, and they soon had me packed into bed. But the glory kept shining and bright in my eyes, and the stars going round in my head. This poet, Robert Louis Stevenson, compares the number of stars in the night sky excuse me, at night to several different things. Compares it to the number of people in church, must be crowded, or the number of people at the park must be crowded, or the thousands of leaves on a tree. But it said none of them were as crowded as the stars in the sky. He mentioned several star patterns and celestial bodies. The dog is probably Canis Major. The dog's star would be Sirius. The plow is what we commonly call the Big Dipper. The hunter is the constellation we know as Orion. Polaris is the North Star. Remember, that's what the sailors would have used. A planet. The only one that he mentioned was Mars. What about this line in the poem? And the pail by the wall would be half full of water and stars. Do you know what a pail is? Pail is like a water bucket. And why would this pail be full of stars? I think you're right. I think it's the reflection of the night sky. Must have been a beautiful, bright night. He starts out outside. It's like he snuck outside. And there are people inside in the kitchen and in the living room, and the lights shining out through the blinds. But high overhead, he can see all these stars moving about. They finally realize that he's not in bed. They chase him back to bed, but he's still thinking about the stars. Listen again, Escape at Bedtime. The lights from the parlor and kitchen shone out through the blinds and the windows and bars. And high overhead, and all moving about, there were thousands of millions of stars. There ne'er were such thousands of leaves on a tree, nor people in church or the park, as the crowds of the stars that looked down upon me and that glittered and winked in the dark. The dog and the plow and the hunter and all, and the star of the sailor and Mars, these shone in the sky, and the pail by the wall would be half full of water and stars. They saw me at last, and they chased me with cries, and they soon had me packed into bed. But the glory kept shining and bright in my eyes, and the stars going round in my head. Great way to go to bed. As we talk about the Big Bang Theory, you'll need to know some vocabulary. The Big Bang is a scientific theory of how the universe began. Compressed means to press together into less space. Data, facts or pieces of information that have been collected, often in the form of measurements. Elements, the basic substances found on Earth and in the universe, each made of only one kind of atom. Evidence, something that makes a statement clear and believable. Expanding, opposite of compressed, becoming larger, increasing in area, spreading out. Phenomenon, an interesting fact or event that can be studied. Theories, suggested or widely accepted explanations for why things in the world happen. We're going to review just a tad. What have we already learned? If something is true, I'm going to read some statements. If one of these statements is true, stand up. And if the statement is false, I need you to tell me why it's false. So you'd raise your hand and tell why it's false. Number 1, a star is a star. All stars are the same. That's false. All stars are not the same. They are different in age, they're different in color, temperature, size, and brightness. Number 2, reddish stars like Betelgeuse are not as hot as bluish stars like Rigel. That's true. Bluish stars, bluish white stars are the hottest. Reddish stars are, I don't want to say coolest, the least hot. They're not cool. Number 3, our galaxy, the Milky Way, is irregular in shape. That's false. The Milky Way is a regular spiral galaxy. Its arms are about the same length, they're about the same distance apart, and they make a regular shape. Number 4, our sun is a yellow, medium-sized, medium-age star. That's true. You should stand up. Number 5, galaxies are clusters of billions of stars. True. Number 6, another name for the North Star is Sirius. False. Polaris is another name for the North Star. We call Sirius the dog star because it's in Canis Major. Number 7, stars contain a lot more mass than Earth. That is true. Remember, the universe contains billions of galaxies and extends to vast distances, really beyond our imagination. So, listen to this theory coming up. The Big Bang Theory is a modern theory based on a great deal of evidence from observations, measurements, thinking, and discussion by scientists. And what do you think a Big Bang Theory might be about? Put aside television. We're talking science here. Yeah, it's a theory about how the universe begins and spreads out and ends up with suns and planets. Let's read. We've been talking a lot about the universe these last few days, but what exactly is the universe? The universe is everything that exists, all matter, all energy, and all the space between things. Look around you. Look at the room you're in, at the people who are around you, even at the air you breathe. It's there, even though it's kind of hard to see. Think about your school, your neighborhood, your community, your state, your country. Picture the whole earth in your mind. Picture all the oceans and mountains, animals and plants, rocks and water, all of the things that you have ever heard of or seen on the earth. All these things are part of the universe, but the universe is much bigger than all of these things on Earth. The sun, the 8 planets in our solar system that orbit the sun, and the huge distances between them are all part of the universe too. So are all of the other objects in our solar system, all the satellites that orbit the planets, the asteroid belt, comets, meteoroids. But the universe is still bigger than the solar system. When you look up to the night sky, you sometimes see the moon or the planets. Those are part of the solar system. You also see beyond our solar system stars and constellations that are part of our Milky Way galaxy. The Milky Way is huge, and every single part of it is also part of the universe. There are billions of stars in our Milky Way. The Milky Way galaxy is enormous, but the universe is even more astronomical in size than the Milky Way. If the sky is very clear and you know where to look in the night sky, you can see another nearby spiral galaxy. That's right, the Andromeda Galaxy. Like the Milky Way, it is a spiral galaxy, but it may have up to twice as many stars as our Milky Way. Scientists believe there are billions of galaxies, each containing billions of planetary systems, and all of them together make up the universe. But the universe doesn't just include the matter or stuff that the stars are made of. The universe also includes all energy, time, and space. As you can tell, the universe is big, and it includes things we can see as well as things we can't see. In fact, the universe is so big that we don't even know for sure how big it is. But just because we don't know exactly how big it is doesn't mean that we can't study it and learn more and more about it. Scientists learn more about the universe every day. The new discoveries that they make help form ideas or theories about the universe. A theory is an explanation about something or a reason for something. Scientific theories are not just guesses, they are explanations based on evidence or information that scientists get by making observations and taking measurements. Frequently, there are several different theories that seek to explain the same phenomenon, so scientists gather new data to help select between these theories. They share the data and study it to look for patterns and answers to their questions. When new evidence is discovered that supports a theory, scientists' belief in that theory is strengthened and it becomes clearer and more certain. When something new is discovered that goes against a theory, the theory can be changed or readjusted to take the new evidence into account. Sometimes new evidence can show that a theory is totally wrong, and then a new theory would take its place that explains the evidence better than an old theory. Here is an example of a theory that changed based on new evidence. For many, many years, humans have looked up into the sky and observed the stars. They have developed stories and theories to explain the universe. In the distant past, most humans believed the theory that Earth was the center of everything that was known. But then, in more recent history, around the time that Columbus made his famous voyage from Spain to the New World, scientists like Copernicus and Galileo discovered new evidence that proved that that was not true. So, a new theory that Earth was not the center of the universe took its place. Today, there's a common theory about how the universe first developed, called the Big Bang Theory. It is a theory that is well tested and widely accepted by many scientists, but not by everyone. The Big Bang Theory seeks to explain how the universe may have come to be, and it begins with a tiny speck. Right? According to the Big Bang Theory, before the universe was the way it is today, it was believed to be very different. There were no billions of galaxies. There was no Milky Way. There were no stars at all. No sun, no solar system, no planets, no Earth, no moon, no asteroids, no comets. There may not have even been time or space. All of the ingredients that make everything we see today were there. They were just in a very different form. It's hard to imagine, but the Big Bang Theory traces the universe back to a point where all of what we can now see in the universe was compressed into a teeny tiny speck. This speck was jam-packed full of, well, everything. It was unbelievably dense and crowded. This speck was also super hot, hotter than anything on Earth. hotter than our sun. Around 14 billion years ago, something amazing happened to all that compressed stuff. Kaboom! A bursting forth, a moving outward, a rapid unfolding. It's been called many things by many people, but this amazing thing that happened is believed to be the Big Bang, the birth of the universe. It was hot, it was sudden, and it was powerful. In a fraction of a second, space that had not been there before was suddenly everywhere all at once. Tiny new particles formed and began crashing into each other, creating energy, and eventually joining to form larger bits of matter. The universe kept expanding and expanding, all of its matter spreading out as the universe kept getting larger. And as the universe expanded, it began cooling down just a little at a time. According to this theory, the newborn universe was nothing like it looks now, an estimated 14 billion years later. Back then, there were no stars yet, and there wouldn't be for the first 100 million years after the Big Bang. The universe kept expanding and cooling. Substances kept crashing into each other, and brand new bits of matter were formed. Eventually, new gases formed. As these gases began to cool, they collapsed because of gravity and formed the first stars. The universe kept expanding and stretching, and more stars were born. Then galaxies formed. About 9 billion years after the Big Bang, our sun and solar system were born when gases collapsed in on themselves and formed our sun. That was believed to be a little over 4.5 billion years ago. But the expansion of the universe and the creation of new stars still goes on today. Many scientists believe that the universe is about 14 billion years old, but no one on Earth has been alive nearly that long. Even Earth hasn't been around that long. The truth is that no human being saw the universe as it was being formed. So how did scientists come to believe this theory is true? That's a good question. You know how you sometimes make predictions before you hear a read aloud? Well, over many years, scientists have been making predictions based on 3 pieces of evidence that they have observed to be true. This evidence supports their prediction that there was a Big Bang. Number 1. The first piece of evidence that supports the Big Bang theory is that the universe is expanding. Remember how we said when the Big Bang happened that there was a sudden unfolding and spreading out of the universe? Excuse me, allergy season. Whew. The expansion today continues, and it has never stopped. Scientists have taken many measurements to prove this to be true. The data that astronomers have gathered are evidence that the galaxies are still moving farther and farther away from each other. And the farther away the galaxies are, the faster they're moving. Because scientists know that galaxies are now moving away from each other, it makes sense that they were closer together in the past. This is exactly what the Big Bang theory says, that about 14 billion years ago, everything was all together in one single incredibly hot, dense speck. The second piece of evidence in the discovery is the discovery of something called the cosmic microwave background. Remember how we said when the Big Bang happened, everything was incredibly hot and then gradually cooled down? The cosmic microwave background is believed to be the glow or leftover heat from the Big Bang itself. This glow or heat does not come from any object in the universe, but it has been discovered to exist everywhere in the universe. Microwaves are one of the types of light energy given off by the sun and other stars, and even though they are invisible to us, scientific instruments allow us to view them. The Big Bang Theory predicted this leftover microwave light energy would exist in the universe, and it was indeed discovered in the 1960s. The third piece of important evidence that supports the Big Bang Theory is the amount of the very lightest elements that exist in the universe. Some elements are heavier, like lead and silver, and some are lighter, like hydrogen and helium. The Big Bang Theory predicted that these lightest elements were created in specific amounts shortly after the Big Bang occurred. By measuring and collecting data, scientists have found that the amounts of the light elements in the universe today are extremely close to the amounts of light elements that were predicted by the Big Bang Theory. The Big Bang Theory seeks to explain how the universe may have first come to be. These three pieces of evidence are great examples of how actual measurements of the universe support and strengthen the idea that the universe began with a kaboom, a rapid and sudden expansion known as the Big Bang. For many scientists, discovering these three pieces of evidence that support the Big Bang Theory has been a real blast. Often in science, finding answers leads to new questions. As astronomers find more and more evidence to support the Big Bang Theory, they also continue to ask new questions and continue to discuss this theory. Maybe someday one of you will help to present a new theory that will include parts of this one or that is completely different.
Happy Monday. Just the FYI, there are copies.
Sorry about that. We'll continue. I'm going to back up and read just a little bit. The Big Bang Theory seeks to explain how the universe may have first come to be. These three pieces of evidence are great examples of how actual measurements of the universe support and strengthen the idea that the universe began with a kaboom. Often in science, finding answers leads to new questions. As astronomers find more and more evidence to support the Big Bang Theory, they also continue to ask new questions and continue to discuss this theory. Maybe someday one of you will help to present a new theory that will include parts of this one or that's completely different. But for now, scientific evidence points to the Big Bang. So, what is a theory? A theory is a suggested or widely accepted explanation for why something happens. And how is a theory different from a guess? Well, a theory is based on a lot of experiments, observations, and data. What does the Big Bang Theory explain? This theory is an explanation astronomers have for how the universe began. What was the universe believed to be like before the Big Bang? Oh, it was a tiny point or speck. Everything in the universe was compressed into one tiny point. It was very hot and very dense. We're not exactly sure where that tiny speck came from. Something to keep working on. Another question. Describe what nearly all astronomers believe happened at the very beginning of the Big Bang. The universe expanded really quickly from a very tiny speck, and all of the material was flung out into the universe and began to cool. You heard in the read aloud today that according to the Big Bang Theory, after the universe's first quick expansion, new matter formed and darted around, and then the then small universe. And what happened when the new bits of matter slowed down? They began to stick together, forming larger bits of matter, and then began to expand and cool down. What kinds of things do scientists do to gather evidence? Well, they make observations through telescopes, they take measurements, they collect and share their data to study it and to look for patterns and for answers. Can you summarize the three major pieces of evidence that has led many astronomers to believe in the Big Bang Theory? Number one, astronomers observed that the universe is expanding. 2, there's a lot of leftover microwave energy. 3, the predicted amounts of light elements closely match the actual amounts in the universe. So how would you describe the size of the universe before the Big Bang? All of the matter of the universe was in one tiny, dense speck that's too small to even imagine. And how would you describe the size of the universe today? The universe is still expanding, and it is so vast that it is hard to imagine. The author of The Big Bang writes about events that began long ago and far away. Describe what it's like for you to think about and imagine such events. If you were a scientist studying the universe and the Big Bang Theory, what kinds of questions would you have? How would you go about trying to find the answer to those questions? Very interesting. Hey, be sure to call me or write me and let me know what your questions are and what your answers are.